So welcome to week 12 of Programming for Engineers. So we'll continue with the Python language. Last time we looked at how to make Python available within the Visual Studio so that we use the same environment. And we took a look at some of the foundations of the Python syntax and data types. Today we'll look at strings, input-output capabilities, and then some of the basics of branching and conditionals, including kind of iterations and loops. So let's look at how Python uses strings. And so I'll go through in a few slides, but also go back and forth with respect of the actual code in the interpreter, and just to demonstrate how things kind of work. So assigning a string can work with double quotes and single quotes. So let me show that. So let's say that you have hi there assigned to a variable, hello there, and then we type hi, and that's the value. So if I go back and use single quotes, you see that kind of the result doesn't change. Oops, I put the enter in the wrong place. Let me do it again. Well, so we do hi, and things are in the same way. So as usual, Python try to be as forgiving as possible. And then we can look at creating a second string and name. And so you have hi, hello there, name Anna. And then we can look at how, in simple way, one can combine strings together. And so Python overloads the plus operator and make it into a string concatenation operator, so that one can use kind of in an intuitive way. So this is kind of the result. Greet equal to hi plus name. Look at greet, and so you see that it's a single string. There is a concatenation of the other two. And so one can also add additional spacing. So you can combine variables and strings that you build on the fly effectively. So you have greeting, hi, plus another string, in this case an extra space, and then you have. And so in principle, you can kind of keep going and use more facility. In particular, the multiplication is used similar to what you would do in integers as a way to concatenate multiple times. So for example, here we can take hi there name, multiply 3 times. Now see the variable silly will have hi there Anna. So you see how the multiplication, similar to you would have to, with the integer, it just add multiple times. Now, what's also interesting is to see that, as in C++, the string is really an array. And so you can actually access portions of the array with the referencing to a particular element. So, for example, we can do silly with 0, which is the first character, or we can do silly 0 colon 5, and so that's the substring from 0 to 5, and you get hello out of the string. And so here you can address different portion of the string very easily by treating the string as an array. Now we're going to look at how to get things in input, and also how to mix objects like integers with the string representation of such objects. So let's say we start with the variable x, and when we print, effectively, we get the string representation. So in my at the first impression, you might have a hard time distinguish one from the other, but then you can see that there are some subtle differences, because when you do print statements or conversions on the fly, the integer gets converted into a string, and that follow a certain set of rules. So let's start with, say, assigning x equal 1. And so now I do x and I get 1, which would be the same if I had a string. But now let's do x str, so the string str of x. And so now we see that x underscore str is also 1, but now you see that is a 1 with quotes. Now we can also now start looking at printing the values of a string and then connecting that with the expression. And so here I say my favorite number is 1 dot x equal 1. Notice that there are no spaces here, but because x is converted from integer to a string, that gets added automatically. So if I were to do the same with the string itself, sorry, I used the transpose that, x underscore str. And so here you see my favorite string is, so we have the comma that add the additional characters, but I could now add so now this is a string, so I don't need to do the comma to do a sequence of things. And so here now things are concatenated together. And so if I want to go back to the same representation as before, I would have to manually add my spaces. And so this result look the same as this. So just to recap, there is a difference between printing a sequence of objects separated by a comma, so giving multiple arguments to the print statement, versus concatenating the objects, here you see, as a string and then printing them. So the print function does additional help by introducing those additional spaces and making the print kind of more visually pleasing. So, and so those are expressions that you'll see in the slides. So now if you want to go after creation of strings on the fly, not assigned directly, then you can actually use the input function. So where you can then type things at runtime instead of having that assigned, so that your program can actually change during the and not always be the same in the execution. So let's see, I'll just copy the command here. One second, I'm having trouble doing that. And so, oops. So here is my name input, please type my name. So here is using the input function. And here I can say type Valerio. And so now my name is assigned to the string Valerio. And so similarly, we can do instead of, oops, let's say we want to do a number. And so please type number, similar thing, you get a prompt and I type a number. So notice that this number get assigned to num, and here it's actually num is a string, not an integer, unless I do the conversion to an integer itself. So if I really want to get an integer, what I would have to do is apply the conversion function int to create an integer. And so if I do 13 and then I type none, now it's actually an integer, not a string. So those are very simple variation, but now you see that in a very simple way, kind of natural way, you get prompt, read the number and evaluate. And so you have this three-stage process where first you print a prompt, which is the string you provide to the function. Then the user can type whatever is appropriate. Obviously, you have to see whether they match what you expect, and then the variable gets bound to the actual value. Obviously, in this case, int, you want to make sure that the string is such that it can be converted to an actual integers. So if one types multiple numbers together, there is kind of a way to deal with that. And so instead of creating kind of a loop, so one can actually take multiple numbers together. So let's try this way. So here is a my name input, please type your name. But now this is kind of the old one. So here I have numbers input, then I can type a few numbers, 5, 10, 15, and 20. So now numbers, it's a string that contains all those values. So what we can do is to make things simpler, is to actually split the numbers. So numbers now equal numbers split, and we say the space is the separators. And so now if I evaluate, I get a list or a sequence of numbers, each of which it's a different value. But remember, now it's still just a sequence of numbers. And so it's not a string yet. It's not a sequence of actual integers, a sequence of strings. So if I now apply this map, so so I would have to apply the function int to each value. So this is what the map function does. I gave it a list. I provide the function, and that function gets applied to everything, and the results get formed into a list. So now numbers, instead of being a list of strings, is a list of actual numbers. So this is kind of the process we just went through. We read a bunch of numbers as strings. We split them using specifying the separator. Notice that this could be also comma or something else you provided explicitly. Then we convert the list of strings into a list of integers by mapping, which really is replicated application of the same function to all the elements in the list. And then we get the list of integers as well. Now, moving on to other basic stuff, comparisons in Python are kind of similar to C++. So if I have two variables, I and j, I can check one is greater than equal, equal, or different. and so in all the variations. And so that can be used to use that into conditional codes, right? And so one can write an expression that might be have a true or false value. So let's say that now I go back to the code. I say I equal 1, j equal 2, right? And so now I can write a Boolean expression, and second, copying the code. Just let me type it directly. So if I say I smaller than j, and I equal to 1. So this is writing an expression, and say check first if I is smaller than j, and that's true, 1 and 2, and also check whether I is equal to 1. Obviously, you can do all the variations you want, and this can be false. You can also use the not operator. So if I do not I equal 2 is true, and if I do not equal 1 is false. We can also do the typical conditional with the or, and so I can say I equal 2 or j equal 1. And so now those are both false, so obviously return false, but let's say one of them is equal to 2, I equal to j equal 2, and that becomes a true value. And so as usual, this becomes the foundation of conditional statements. And so, for example, if I take a few values A, B, C like this, I can write conditional statements and get the proper value here. So this is not, I mean, worth the time of typing it, everything, but you can see you have 3 variables. You start composing the conditional statements, and then depending on the output, you have 3 possible results. If you have a loop, you can do a repeated execution based on the true value of a test function. Let's say you have n equals 0, and then you do a while loop n smaller than 5. You can do print n and then increment n. So this keep reevaluating the loop. And so as you get the result, it's 0, 1, 2, 3, 4. As soon as this test becomes false, so n is equal 5, so it's not smaller than 5, the test fails, and then you get outside of the loop. Now, in for statements, there is a difference, an important difference with respect to C++, and in particular is that instead of having a sequence of expressions that get evaluated, you need to provide as a sequence, as a list, or some other form of sequence or an array, directly the values that you want to use. So this is the form. Variable in range is a way to build the sequence on the fly. So if you say range 5 is really going to do 1, 2, 3, 4, and so on. I'm sorry, 0, 1, 2, and 3, and 4, so as I express here. And then you can start adding things, and then you type the value and see the value at the end. So the loop is executed, but you need to have upfront the list of value. And this range function is kind of a utility function that lets you build those when you have the typical iteration from a list of integers. but this could be any list of any values that you're interested in. So you know in advance, in some sense, how long this loop is going to be. So the range function can have also start and end value and even the stepping. So this is kind of to reproduce what we have seen in C++, but kind of restricted to integers. This simplified the syntax of the for loop. Here, a couple of examples. You do I in the range from 7 to 10, but you go through every element. Kind of the stepping is 1, or you do 1 to 5, but then you step 3. So this executed just twice, 1 and 4, as you see. So there is kind of all kind of variations, but the for loops are kind of very simple. And as you notice, the indentation says what instructions are inside of the loop. Now, to conclude, the break statements allow to stop the iteration even if you're not finished. For example, here we could put an if statement and show how to get out of the loop before you go through the iteration. So here, for example, I could say if I greater than a break, and so that will get out and now finish the computation, the skip the final part of the loop. So this concludes this presentation, again acknowledging the source of some of the material. And then in the next class, we look at more advanced features of the language.